I referenced the unified modeling language in the previous video, and I didn't go through all the details of it. Maybe it made some sense when you first looked at it, but let's take a little bit of time to look at exactly what UML does when it comes to defining objects and classes more specifically. So the unified modeling language is built by these three guys. So that's James Rumbaugh, Ivar Jakobsen, and Grady Booch. I don't know if it's the order of them. I think the guy in the middle is Jakobsen. I think that's the order of the three of them, but I could have a couple mixed up. And they were three computer scientists who each had ways of drawing out object oriented design, and they got together and they agreed on what is now called the unified modeling language. And so when we talk about classes, there's many aspects to UML. We're just going to focus on classes. When we talk about classes, a class is a box like this one. And the top thing you see in the class is the name of the class, a game board. These are called compartments inside of them. So the top compartment is the name of your class. The middle compartment is the attributes, and the bottom compartment is your methods. These compartments can be any size they want to, and theoretically you could draw this as a cloud, you could draw this as a rounded rectangle, you could draw it as a circle. But if you want to stick to UML, if you want to stick to the conventions, you want to use something that looks a lot like this. Um, the reason for that is when I see standard things in the conventions, it communicates a lot of detailed stuff to people. I know where the attributes live in the middle box, for example. I know the name of it's up top, and I know that the methods are in the bottom. So that convention helps us communicate information quickly. You know what an object knows, forward player turn. You know what an object does, make a move based off the name of the object. And more importantly, you also know that it communicates with other objects based off of these lines between them. If two objects don't have a line between them, then generally what that means is they don't communicate, or at least they don't keep track of each other. And so what do I mean by that? Well, think of it this way. You're taking a class with me. So right now, I am in your directory as teacher. There's some, maybe you saved my address in some way or another. Now, there are people we only communicate with temporarily. So if you call, for example, customer service, you talk to a person and you have a deep interaction with a person for a few minutes, but it's not like you keep that person's phone number. You don't keep track of them. You have a relationship with a company which happens to be serviced by a person, and which person you talk to is kind of just happenstance of whoever gets assigned the phone call when you call in. So it is possible for you to interact with another object in an object-oriented system that's passed to you by a parameter, for example. But that is not a relationship that I care about in the object-oriented sense. That is just something that's temporary. These are the objects I keep track of and work with on a regular basis. And so there's a lot of flexibility, but that's what this line means between them. So the association is the formal definition of a relationship between two classes, but that association isn't always there. I could theoretically have a game board on its own without any players, or maybe only one of the two players that are out there. And so when we're talking about objects, objects have links to other objects. So classes associate, define relationships that might be there, but they might not be there. You might have a spouse or you might not have a spouse. That's okay, but we have that construct in humankind known as a spouse. It's a role that could be filled, if you will. And that's important for objects as well, because it's really important that you understand the distinction between objects and classes. Classes define potentiality, objects model real world things. So a class describes, for example, every car that could be sold by a company. An object is a specific car driving around on the road. So think of the class as kind of like a cookie cutter, and the object is the cookie. The cookie cutter defines the shape of the dough that's going to be coming up, but you still have to cut it and build a cookie to eat one. I don't eat cookie cutters. And so it's a really important distinction that the class is there to define exactly what a object knows. It's there to define what an object does. It's there to define the generalized relationship with other objects. But it's the actual cookie, the actual objects that define what the relationship is. Every cookie in this cookie jigsaw puzzle doesn't connect to every other cookie. It at most connects to four other cookies, up, down, left, right, if you will. Um, and that relationship is important. Those are the ones I keep track of, but I don't keep track of every cookie in the whole system. And so when we think in terms of objects instead of, functional programming, which you've probably been doing up till this point, it's important to start seeing that in object orientation, everything is an object. And so if you look at this, I think it's Target, there's a cash register. And there's a person who works at the cash register, and there's bags, and then there's the shopping carts, and then there's the little terminal to put your credit card in, and then there's all the different products that come across, and then there's a receipt that gets generated. Those are all objects that live in the real world, and each of those objects have a purpose for that transaction. They all play a role in that transaction. Now, when we move from the real world into the virtual world, what we want to do is we're going to create a class that provides a representation of the real world objects. And we want to make those classes intelligent. We want to imbue those classes, if you will, with the intelligence of what the people would be doing otherwise. So I don't need a cash register and a clerk, because I can take all the smarts that a clerk has and I can put it into the cash register. I don't need a customer and a shopping cart if I can take all the smarts of what a customer does in putting stuff into their shopping cart into the shopping cart itself. And so I might have a customer that represents who's buying the thing, what their name is, what their preferred account is, all that sort of stuff. But they wouldn't do, that customer wouldn't be holding on to the objects. The shopping cart would hold the objects. And so what we're going to do over this class is we're going to go try and attempt to see objects. We're going to try and, like we were just talking about there, take real world things and turn them into virtual objects. I'm not trying to right now teach you all of that. This is not an object-oriented design discussion, but it's more of setting the philosophy. So as you work through assignments, I want you to think about how I've chosen to break things up. As you build code related to objects, there's an implicit design that I have constructed in there. Not necessarily a correct design, not as being it's the only way to do things, but it's the way I chose to do stuff. So think about how I'm breaking this stuff up as well as you write the objects, because that design is very related to solving problems, the way you'll learn to solve problems later on your own